Alright, dear children, let's continue again with the concept of conduction of heat in metal rod. Now, in the last YouTube video, children, you learn about steady state. Okay, but in that particular state, we had considered that there's some amount of heat that is goes out through this side of this cross section through convection. But this heat can also be trapped. Okay, this heat can also be trapped. But how can we trap this heat not to go out from this side of the rod? Simply by covering the rod, okay, the side of this rod, okay, by some non-conducting material. Non-conducting material means like non-insulating material. So if you cover this metal rod by insulating material like non-conducting material, under this state, that means under this state means this steady state, what happened? Whatever amount of heat that is received by each cross section of the rod will totally transfer to the next cross section. The amount of heat that is absorbed by each cross section rod is simply totally transferred to the next cross section of the rod. Okay, so in this particular state, means the steady state, the rate of conduction of heat in the rod, okay, depends only on the material of this rod. The material of the rod is actually expressed by the term known as conductivity of the rod. Conductivity of the rod. Because different metallic rod have different conductivity. The conductivity means the amount has the ability to absorb and transmit the amount of heat, okay, to every cross section of the rod. So under this case, so from hot end, if you move to the cold end, or that is from this end where you are supplying the heat to the other end, so that the distance increases. When the distance increases, the temperature decreases. But under this state, as I said, when you cover this side of the rod, okay, with some non-conducting or insulating material, then whatever heat absorbed at this end will transfer to the other end. Okay, so under this case, what happened? The temperature of the different cross-section rod keep on decreasing, but it decreases what? Linearly. It decreases what? Linearly with the distance when you move from the hot end. Okay, distance you move from the hot end of the what? Rod. So this state can also be achieved under this metal rod, and as of course the state is called what? Steady state. So children, as I said already, when you draw a graph between temperature versus distance, that we move from the hot end to the other end, then when the distance increases, the temperature decreases. But how temperature decreases when distance increases? Linearly. That's why your graph is a straight line graph, but with decreasing what? Temperature with increasing what? Distance. So when distance increases from hot end, that means when you move away from hot end to the other end, okay, then what happens? The temperature decreases, but it decreases linearly. That's why the graph is a straight line graph, okay, and it is this graph so that theta means temperature decreases linearly with the distance. But this is true only when you cover the side of this cross section of the metal rod with some insulating material. Okay, so this is also one of the state which achieved, that is called steady state. Now under steady state, there is a surface that is defined, and this particular surface is called isothermal surface. So we are moving to next surface to define, called isothermal surface. Now what do you mean by isothermal surface? And what is the meaning of isothermal? Isothermal related to that where the temperature remains constant. Thermal means heat that is determined by the degree of hotness or coldness, which is called temperature. And isothermal means the temperature constant. Temperature what? Constant. And children, remember this word, isothermal word, we even use in one of the chapter. Okay. So what do you mean by isothermal surface? The surface at every point on which the temperature remains same is called isothermal surface. So simply, what is the definition of isothermal surface? The surface at every point, surface at every point of which, okay, of which the temperature, okay, the temperature remains same. Temperature remains what? Same. Is called what surface? Isothermal surface. Like, let me just consider with the help of diagram. Okay, now let me just draw a diagram of the surface, and usually what is a metallic rod only, but what type of shape I consider? Say this shape. Okay, so I'm drawing separately just to make you understand about the surface. Okay. So children, if you look at this particular diagram which I have drawn, this is a metallic rod, but in what shape? Rectangular shape. A rectangular shape, what rod? Metallic rod. Okay, and this rod, let me just consider, has two cross section and two surfaces, and I'm consider this is other cross surfaces. Now this surface is A, and I consider this surface is what? B. Okay, now this cross surface are separated by, say, a distance what? L. Just considering the distance between the two surfaces what? L. And I consider the heat is flowing perpendicular to the surface. Heat is flowing perpendicular to the surface. Means this is the surface. Okay, with this respect to this surface, this arrow indicates that the heat is flowing perpendicular to the surface. So this surface has number of cross sections, number of points. So number of what? Points. So in the steady state of metal rod, the temperature of every cross section of the rod become constant. Means this cross section has a temperature, and I consider that temperature, say, θ1, and this cross section has a temperature, and that means temperature, say, θ2. But as far the isothermal surface is concerned, the surface at every point of which the temperature remains same. Whether this point, whether this point, whether this point, whether you measure the temperature with the help of thermometer, at this different point of this surface, the temperature remains same. And that particular surface is called isothermal surface. So this A is what surface? Isothermal surface. Isothermal what? Surface. Similarly, this surface is called what surface? Isothermal surface. Isothermal what? Surface. Now, why this is called, this A and B are isothermal surface? Because this surface has a cross section. This is the cross section where the surface at every point, so every point of the surface where the temperature remains same. Whether you measure temperature at this point or this point or this point or this point, the temperature remains same. And that surface is called isothermal surface. But at this surface and this surface, there is a distance, and they are separated by a distance, say, L. So when this surface maintains a temperature, say, θ1, this temperature remains same throughout the surface. If this surface maintains a temperature θ2, then the temperature θ2 remains same throughout this surface. And these two surfaces are called isothermal surface. Okay. Now, one important point that you need to keep in mind regarding this isothermal surface is the direction of heat flow. So this arrow indicates the direction of heat flow. The direction of heat flow should always be perpendicular to the isothermal surface. So one note you have to write it down, that is the direction of heat flow. The direction of what? Heat flow is always what? Always perpendicular. Remember this. The direction of heat flow is always perpendicular to the what surface? Isothermal surface. Isothermal what? Surface. So in the diagram, you see there are two isothermal surfaces. One is A, another is B, have different temperature, θ1 and θ2. But this surface is such a surface where the heat flow is perpendicular to the surface. That's why this is one of the important points you need to be take a note. Now another property, as I said, or note that you need to keep in mind in isothermal surface is two isothermal surface. You can see two isothermal surface can never intersect. They should be separated by a certain distance. There must be a gap between the two surfaces, but two isothermal surfaces, okay, can never intersect. Two isothermal surface can never what? Intersect. So these are the two properties, as I said, for isothermal surfaces. Now, isothermal surface can be any surface of any shape. It can be a plane, it can be a sphere, it can be a cylinder, any shape. But out here I have shown with a plane. A rectangular box with this plane surface is a what? Isothermal surface. Okay, so this is the concept of isothermal surface. Now, one important factor, a term that we need to define under steady state and with respect to this isothermal surface is called temperature gradient. Children, out here there is a term out here I am using, that is called gradient. Gradient related to any physical quantity is respect to distance or length. The temperature can change. That means there is a change in temperature with respect to distance. And the rate of change of temperature with distance between two isothermal surfaces actually is called temperature gradient. See, the rate heat is flowing from this end to other end. So there is a distance between the two surfaces and there is a difference in temperature. And when you move from this surface A to surface B, temperature decreases. But this temperature decreases with respect to distance. And this rate of change of temperature, or we can simply call as the change in temperature with distance between two surfaces, is actually called as what? Temperature gradient. So children, whatever explanation I made for temperature gradient, so the same explanation I have written in the form of statement saying that the change in temperature with distance between two isothermal surfaces is called temperature gradient. So with respect to this diagram, we can measure the temperature gradient. So this surface has temperature θ1, this surface has temperature θ2, but heat is flowing from A to B, means definitely this surface where temperature is θ1 is greater than this surface where temperature is θ2. So temperature is changing with respect to distance, and the distance between the two surfaces is how much? L. So what is the temperature gradient? It will be θ1 minus θ2 by what? L. So look at the expression, children. Temperature gradient between these two surfaces is θ1 minus θ2 by L. Now why θ1 minus θ2? Because as I said, θ1 is greater than θ2. So this is the change in temperature divided by length. And this θ1 minus θ2 by L measures what gradient? Temperature gradient. Now from here you can easily guess what is the unit. The unit will be, temperature unit is degree Celsius, length is what? Meter. So the unit can be expressed by degree Celsius per meter. See, temperature unit is degree Celsius. Change in temperature is also measured by degree Celsius. Length is measured in meter. So if I take meter in the numerator, it is per meter. That's why the unit is degree Celsius per meter. But other than degree Celsius per meter, temperature gradient is also measured by Kelvin per meter, because SI unit of temperature is what? Kelvin. And this change in temperature is measured by Kelvin. And SI unit of length is what? Distance is meter. So it is Kelvin per meter. So children, look at the units. Degree Celsius per meter or Kelvin per meter are the unit of what? Temperature gradient. And remember this part, temperature gradient is a vector quantity. It is a what quantity? Vector quantity. Vector quantity means it shows the direction also. In which direction this temperature is changing, or it is the heat is flowing, and heat which flow in particular direction, that is the direction of temperature gradient. Because if you look at the diagram, heat flow from this surface A to surface B, where the temperature is decreasing, the temperature gradient is also taken in the direction of heat flow. So these are the detailed explanation of isothermal surface and temperature gradient. Now in the next YouTube video, we derive important expression of coefficient of thermal conductivity.